Good. Hi, everybody. We've been learning a lot at this conference. I've been learning especially a lot about risk, how to define it, how to analyze it, how to predict. I'm definitely not a risk expert, so I thank for the knowledge that I've learned so far. For me, the interesting question is now if we could define risk and manage these risk-type information, what do we do next with this information? What's our next step? How do we crystallize our efforts in a productive way forward and with real action? Well, I suggest we look at waste. I'm sure you have your own ideas. I'm sure you've developed your own ideas. But for me, waste is what I do. I'm a sanitary engineer right down the street. So typically, waste is kind of looked at, there's different ways to define it. You have this phrase, one man's trash is another man's treasure. But I like to define waste as simply an inefficiency of a production or a consumption network. And as a sanitary engineer who tries to dabble in sustainability, I don't look at waste as kind of an inevitable byproduct of industrialization or human activity, but rather a resource base on which to draw upon to design these next generation synergies and systems which tackle multiple problems simultaneously. And so, I don't have these beautiful graphics like you guys have. I'm just a basic engineer, so I have one example here. We call it the 4 elements for short. It's basically a comprehensive system to deal with waste. It can be used anywhere, but we're using on the example of Bangladesh. And I'm sure you've all studied Bangladesh so far. If you're talking about multiple problems simultaneously, Bangladesh is a great place to start. We have basically, I'll give you a real quick, the spiel, because I need at least 4 minutes to describe this whole thing, and I only have 3. Basically, we have combined organic waste coming into a solar sludge dryer. I can't use this green thing, sorry. It's reduced moisture content down to 20%. Then it's pyrolyzed. The biochar is then incorporated long-term into the soil using a halophyte greenhouse. One of the major problems, many major problems in Bangladesh is you have soil salinization. You have your soil, which is losing structure, it's losing integrity, and therefore you lose your flood retention volume, your flood retention capacity, and you increase your disaster risk. So if we can slowly over time rebuild the soil substrata, the structure of the soil, you are improving your resilience. At the end, we have using the reject thermal energy from the pyrolysis plant, we actually thermally desalinate water, so we're also producing clean water. This is also a huge problem in Bangladesh. You have basically no fresh water, water everywhere, but not a drop to drink. And this disproportionately affects women who are basically spending most of their days gathering water, and children as well. So we're basically trying to solve all the problems at once using everything we can. No, we can't do that. What we can do is look comprehensively. So much like Dr. Patel, I don't have beautiful graphics, but I do like me some good tabulated data. So we have some really basic process flows. This is the first iteration. This can be scaled to different situations based on your priorities, based on your capacities. I'll be happy to answer more specific questions in terms of outcomes later, but one thing I really want to focus on is this isn't a silver bullet technology. This isn't a magical thing that's going to solve all the problems. There is no such thing as a silver bullet technology. We can't expect a technology to solve these problems, but taking a comprehensive approach, a systematic approach where you look at all the problems at once, you look at your heat, your matter, your energy exchanges, and doing your best to kind of waste nothing, it's a step in the right direction towards improved resilience, reduced risks, and human well-being. So, thank you. Do I have all the time left?
Thank you.